In this lecture, we will cover the effect of P-delta analysis and how to consider it in ETABS. The P-delta analysis or effects in a given story are caused by the eccentricity of the gravitational load above the story, which produces the secondary moments in the story. The P-delta analysis is different from a simple linear static analysis. The analysis considers the effect of load on the deformed shape of the structure, causing an amplification in the structural deformation due to these secondary moments, which are of course generated due to the load and deflections. Let's see how to apply this option in ETABS. Using the previously modeled structure with the same defined load cases and load patterns, I have dead load as dead finishes and wall parapet load as dead loads, while the live load case is named as live load. So I'll go to define the P-delta options. There are three different options consisting of two types. The first option is selected when you don't want to incorporate the P-delta effects in the analysis, while the other two types are non-iterative and the iterative. Let's see what are these two types. The types of P-delta analysis in ETABS. The first one is non-iterative based on mass, in which the load is automatically computed from the mass at each level. This is an approximate method which does not require an iterative solution. Providing for faster computation, P-delta is considered by treating the structure as a simplified stick model, a process which is most effective with a simple rigid diaphragm at each level. The local buckling effect is not captured effectively. There's one advantage with this method, that you don't have to define the individual load cases in the P-delta option, while the other one is known as the iterative based on load cases, in which the load is computed from a specified combination of static load cases, then known as P-delta load combinations. This is an iterative method which considers P-delta on an element by element basis. Local buckling is captured effectively. An example application may be when the load includes dead load case and a fraction of live load case. So for accuracy point of view, I'll always go with iterative based on loads. Now we have to define a specific load combination for the P-delta analysis. Some code specify P-delta analysis load combinations while others don't. So for this confusion, CSI suggests a load combination. CSI suggests us to use a load combination of 1.2 times dead and 0.5 times of live load. The reference for this is given as link below, and the notes will be attached in the description. So I'll add the dead loads with a multiplier of 1.2. Finishes load is also a dead load. Wall parapet load is also a dead load, while the live load are added with a multiplier of 0.5. Similarly, live load and reducible live load. Okay, we press OK here and then click on Run the model. So now you see it's running the P-delta analysis. You can also see the show details from here. When the solution of P-delta analysis will converge, then it says 100% P-delta completed. Now it's reanalyzing for updated loads, which is it's applying the P-delta analysis on the previously linear static analysis load cases of the dead load and the live loads. And then it will be amplifying the deflections on the structure, which further enhances the design. The significance of p-delta analysis will further be emphasized in the design part of this course. Now you see the analysis is complete. Now you know how to run the p-delta analysis in ETABS and amplify the basic deflections of linear static case by using the p-delta analysis.